Okay, let's dive right into this explainer. Today we're going to do a fascinating mental thought experiment, and the best part is you get to play the role of the master inventor. We're going to build one of the most important machines in human history, completely from scratch, and we'll do it using nothing but simple logic, problem solving, and, well, a few controlled explosions.
I really want you to paint this visceral mental picture in your mind. Imagine taking a lit firecracker, throwing it into a heavy iron barrel, and slamming the lid shut. Boom! The energy released by that raw explosion instantly launches that heavy lid high into the air. Now, putting your inventor hat on, you look at that violent power and realize it's an absolute shame to let all that incredible explosive energy just go to waste, vanishing into the open sky, right? We need to capture it.
Section 1. Harnessing the explosion.
To capture that energy, your very first mechanical step is beautifully simple. You take that same iron barrel and you turn it completely upside down. Once it's upside down, you attach a connecting rod to the lid and hook that rod to a crankshaft. Because the lid is now trapped within the walls of the barrel, it can literally only move strictly up and down. Congratulations, you've just invented a piston. But to keep this new invention going, we run into a bit of a logistical problem. You obviously can no longer just casually toss firecrackers into a sealed upside-down barrel. So you have to drill a small hole at the very top of the barrel just to drop lit firecrackers directly inside.
Now, what's really interesting about this slide is that it presents a new mechanical puzzle. You drop the firecracker in, the explosion happens, and the immense force pushes our newly invented piston downward. But after the piston moves down, how on earth does it return to its original position at the top to do it all over again? Gravity and the explosion are only pushing it one way. Section 2. Solving the return stroke. To keep our machine from just being a one-hit wonder, we absolutely need a clever way to force that upward movement without wasting extra energy or manually pulling it back up. Being the clever inventor you are, you solve this by adding a brilliant new component, a heavy wheel called a flywheel, attached right to the crankshaft. The secret sauce at play here is rotational inertia. The initial downward blast from the firecracker spins the crankshaft and gets that heavy flywheel moving. Because of its massive weight, that wheel really wants to keep spinning. Its momentum keeps the crankshaft turning, which effortlessly pushes the piston right back up to the top. Just like that, you've created continuous mechanical motion. But let's be real, standing there lighting a new firecracker and dropping it through a tiny hole every single time is far too inconvenient. In fact, it's pretty much impossible. To modernize our machine, you install a massive upgrade. You bolt a fuel injector to the top of the barrel, completely replacing the physical firecrackers with liquid fuel. Alongside it, you add a spark plug, which is designed to act like a tiny lightning bolt, providing the electrical spark to ignite that injected fuel.
Section 3. Fueling the fire.
Okay, we've solved the mechanics, but now we face a major hurdle regarding the actual chemistry of combustion. A sealed chamber contains absolutely no oxygen, so how will the spark plug ignite the fuel? Well, it's a rhetorical question, of course, because it won't. No way. Our brilliant fuel injector and spark plug upgrade is completely useless if there is no air to feed the fire. Fire strictly requires oxygen, and our barrel is completely sealed shut.
So the crucial takeaway here is that our engine needs to breathe. To solve the oxygen problem, you add an intake valve right next to the fuel injector. Now, fresh air and fuel can naturally flow into the barrel together, and the spark plug can finally ignite the mixture to produce power. But as with all great inventions, a new problem immediately pops up. The exhaust gases from that combustion are now trapped inside. They essentially block the fresh air and fuel from entering on the next cycle, causing the engine to lose power and eventually just choke out entirely. To solve this exhaust blockage problem, you simply add a second valve on the opposite side of the top, an exhaust valve. Now the burned gases can smoothly flow right out of the chamber.
Section 4. Automating the valves. We now have an intake valve to breathe in and an exhaust valve to breathe out. But think about the physical limitations here. Trying to manually open and close these two valves yourself is exhausting, and quite frankly, it is completely impossible to do at the insanely high speeds our machine needs to run. So, how do we perfectly time and operate two valves at high speeds without getting exhausted? This is the final major engineering roadblock to making our engine run completely autonomously, without any human intervention slowing the whole operation down.
And this brilliantly illustrates the solution, the valve automation system. Being ingenious once again, you install two camshafts right above the valves. As these camshafts rotate, specially shaped lobes on the shafts push the valves open at the exact, precise microsecond they're needed. But remember, once a valve is pushed open, it doesn't just magically close by itself. Therefore, you add a strong spring to each valve. After the cam lobe pushes a valve open, the spring automatically snaps it back into its closed position, sealing the chamber tightly. It is a flawless, automated mechanical dance controlled entirely by the rotation of the engine itself.
And that brings us to Section 5, the four-stroke cycle. We finally have all the individual pieces of the giant mechanical puzzle. It's time to step back and see them work together continuously inside our barrel, which from this point forward is officially called a cylinder. Watch this beautifully choreographed cycle unfold step by step with me. First, intake. The intake valve opens and the piston moves downward, sucking that vital mixture of fuel and air into the cylinder. Second, compression. The intake valve snaps closed and the piston moves upward, intensely squeezing and compressing the air-fuel mixture. Third, power. The spark plug fires, igniting the compressed mixture, and that massive explosion violently pushes the piston downward. Fourth, exhaust. The exhaust valve pops open, and the upward momentum of the piston forces all the burned exhaust gases right out of the cylinder. Intake, compression, power, exhaust. One complete cycle. And the absolute beauty of this design is that the completion of one cycle instantly triggers the next, with all components working together continuously. This exact cycle is an absolute powerhouse, acting as the foundation for moving massive vehicles, including powering heavy marine vessels right across the water.
Huge congratulations! You have successfully invented the four-stroke internal combustion engine right in your mind. By methodically solving one problem at a time, from a trapped explosion to a return stroke to fueling, breathing, and automating, you've turned a simple iron barrel and a single firecracker into a complex, self-sustaining mechanical marvel. And this isn't just theory, folks. By adapting this incredible technology, this exact cycle of intake, compression, power, and exhaust is used heavily for boat propulsion today. It directly harnesses those controlled explosions to spin a propeller, effortlessly powering massive marine vessels across the open water. It's literally a game changer.
As we wrap up this explainer, I want to leave you with a final thought-provoking question. If harnessing something as raw and simple as a firecracker and an iron barrel can eventually drive a speedboat across the ocean, what everyday reaction will inspire the next great mechanical revolution? Keep that inventor's mindset sharp, because the next big breakthrough might start with a concept just as simple as the one we explored today. Thanks for exploring this blueprint with me, and keep your curiosity fired up.